So how do we relate this idea of warm pool growing in area and how it relates to convection and atmospheric response in thermodynamics and dynamics? The first thing to look at is the so-called column integrated heating. You remember our energy equation from chapter 3, where we related the potential temperature to the heating, diabatic heating in the atmospheric column, and we had talked about Charney scaling 10 to the 6 meters, the weak temperature gradient, and we said the baroclinic processes could occur when the heating diabatic heating can be balanced by vertical advection and radiative cooling. So that relation can be used to express the columnar heating, which also we had looked at in chapter 2. So this is our total columnar heating in watts per meter squared for TJF, MAM, JJA, and SON. Obviously closely relate to the ITCZ in the tropics, monsoonal heating, the pre-monsoon changes happening in terms of the ITCZ crossing, and then you can see the large-scale monsoonal heating with this tilting structure from the southeast to the northwest, and this is what was interesting about thinking about all India monsoon rainfall and its dynamic connection to the large-scale circulation, etc. Right? We also looked at this in chapter 2, where we looked at mean SST and column integrated heating averaged over 1979 to 2001. So this is the long-term annual mean SST distribution in colors. Contours represented the columnar integrated heating. Continuous black contours denote positive heating, and dashes correspond to negative heating, and you obviously can see the relation to SSTs as a threshold where the column heating goes from negative to positive. This we will define as threshold SST and then go forward with that. This is showing the column integrated heating and average column integrated heating as a function of the 1 degree centigrade SST bins, and you can see where the column integrated heating crosses over from negative to positive around 26, 27, or between 27 and 28 degrees. Okay, so this will become key in our further interpretations of the relation between SST and convection. There is also a long-term context to this, which we will come back to. This is looking at pentad columnar column integrated heating versus SST over 1950-54 period and 2000 to 2004 period, with diabatic heating represented as CP, heat capacity at constant pressure times some average temperature times vertical velocity times the static stability term. And you can see that in the 1950s, the columnar heating threshold temperature, where the net heating went from negative to positive, was colder, and these colors, the warmer colors, represent the latter period. And you can see that the along with the global warming that we have been looking at, the threshold temperature has also increased considerably, or at least detectively, and the total column heating has gone up as well. So the question is, as the oceanic warm pool increases, does the region of columnar heating also increase? And if it remains the same, does the intensity of heating increase? And what does it mean in terms of circulation changes? Long story short, you may have already heard that there is an intensification of the hydrologic cycle, in that sense that columnar integrated heating has increased and the circulation has intensified. So you have to explain these individual responses in SST versus columnar heating versus the area over which they occur and the intensity of circulation. So the threshold SST, if you look at two products, one from NCAR reanalysis, another one from ECMWF, both show an increase of net heating in petawatts, as well as the increase in the threshold at which columnar heating switches from negative to positive. So it begins to give you a sense of how the two are related. What happens in the models over the 20th century? So this is observed versus modeled 20th century changes in area of SST greater than 28 degrees centigrade between 1920 and 2000, so pretty much the whole of the 20th century. Here the models used are NCAR CCSM3, the Community Climate System model, so these are the older versions, NCAR PCM1, which is the something climate model, I forgot already, NOAA GFDL, and NASA GIS. They all have slightly different behaviors in terms of El Nino, monsoon, etc. But here we are looking at an integrated quantity like area of SST greater than 28 degrees centigrade. These are coupled models, so obviously they develop their own SSTs along with the atmospheric and oceanic circulations. Okay, so you can see that the models and observations have a reasonable correlation in each model. This is 0.78, 0.79, 0.75, and 0.80 respectively, which is considered very good for these models, even though the explained variance will be pretty low in terms of observations and models. And the area of the oceanic warm pool or the CIH between 1920 and 2000 is shown in sorry, this is the area of the SST greater than 28 degrees centigrade, and they all show a systematic increase. There is some decadal kind of variability in NCAR PCM1, which is a low resolution model which is often used for very long simulations, and both are at NCAR, but this one is maintained separately as a coarse resolution model for long runs. Also does a lot of the IPCC assessment reports and so on, I think. Okay, so nonetheless you can see a systematic increase in the area of the oceanic warm pool. What happens into the future? So if you look again at the observed versus model and scenarios of business as usual and a couple of scenarios A1B, A2, I won't go into the details of which ones they are, but one thing to remember is that when you go this far out, the idea of increasing oceanic warm pool remains. So this is changes in the area of SST greater than 28 degrees centigrade and 26.5 degrees centigrade from observations and from models. So you are showing 26.5 here and 28 over here, and this one increases much more than this one. Already this is a larger area, of course, so the warmer area gets larger. One thing I should point out that these are older scenarios, but also even in the newer models, the early decades, the projections are dominated by model uncertainties, biases, and so on. But as you go to outer years, the uncertainties in the scenarios, which assume everything from population increase, technologies, renewable energies, land use, etc., etc., the scenario uncertainties increase, which means these results depend a lot on what kind of scenario you use, which you can already see here, right? So that's something to keep in mind. If you now consider the area where the integrated columnar heating increases as the dynamic warm pool, and area of SSTs greater than 28 degrees centigrade as the oceanic warm pool, you can see that there is a very surprising result here. in the past as well as into the projections, the area of oceanic worm pool increases quite substantially, but the area where the total columnar heating is increasing is fairly flat. It's almost constant at this 80 times 10 to the 12 meters squared. Okay, if you look at relative net heating with respect to 1995 to 2000, that has increased in the past and will continue to increase. So the area over which you have integrated net heating is not increasing, but the relative net heating within that area has increased and is expected to continue to increase. So what does it mean? Essentially, that means as the worm pool area increases, there are regions which are heating the atmospheric column more and more, but along with it there are probably regions where there is net cooling increasing as well, so that the area of dynamic worm pool doesn't increase. Okay, this we have to look further into, as we will do in the next podcast, but just try to understand that. Just because the area of SST greater than 28 degrees centigrade increases quite rapidly and has done so in the last century, the area of dynamic worm pool, or where the column integrated heating goes up, doesn't increase, but the amount of heating in that area goes up. So there is a corresponding area of increased cooling happening, which is compensating for the increased heating over the dynamic worm pool. This is something we will resolve in the next podcast. Okay, this is the usefulness of looking at the details of how the tropics are changing, and we'll add a little bit more to this as we go forward.